Homework solutions. 9x squared plus 4 is the simplified version, and out of order your x values are 2/3, 1/2, negative 2/3, and 1. If you get this right, it's 1 point. If you get all of these right, it's 1 point. On number 2, it is x minus 6, and the values are negative 2, 1/3, 2, 2.5, 1/3, and 2i. In case you have forgotten, x squared equals a negative 4. If you do the square root of both sides, it takes you back to what we did much longer ago, which is x equals 2i. The square root of negative 1 is equal to I. Square root of 4 is 2. Combine them together to get this. X plus 2 over x plus 5 is the simplified version, and out of order we have negative 1.5, negative 5, 1 2/3, 3, negative 3/4, and 1. On the bottom you have 1 over x plus 5 and negative 2, 2, 3, negative 4, negative 5. Alright, you should have 3 times the quantity x squared plus 4 over 4, or you could have 3x squared plus 12 over 4. And the values are 1 1/3, 1/2, negative 2, and 2. On number 6, 3 times the quantity, 2x plus 3, over 2 times the quantity x plus 4, or you could have had 6x plus 9 over 2x plus 8. And 3, negative 4, 1/2, negative 1. On number 7, 6x squared y. And x cannot be equal to 0, and y cannot be equal to 0 either. For number 8, it's x squared plus 16, and x cannot be equal to 4i. For number 9, 5 times the quantity x minus 2, or 5x minus 10, and x cannot be equal to negative 2. This is one like number 7 on the homework. 24x to the 6th, y to the 2nd, over 18x to the 3rd, y to the 3rd, times 12x to the 4th, y to the 2nd, over 18x y to the 3rd, times 30x squared y over 36 x to the 4th, y to the 2nd. You can break these down one at a time, starting with this one. 6 goes into this 3 times, and into this 4 times, so we have a 4 over 3. X to the 6th over x to the 3rd leaves you with an x to the 3rd on top. You subtract the exponents. And y to the 2nd over y to the 3rd leaves you with a y on the bottom. You subtract the exponents, but it's negative, so it means it goes to the bottom. And negative 1 would make it go to the bottom and just be y. Over here, 6 goes into 12 twice and into 18 3 times, so you have 2 over 3. And x to the 4th over x is x to the 3rd on top, and this is the same as what we had over here, so it's y on the bottom. 6 into this 5 times, and into this 6 times, so 5 over 6. And then this over this leaves you with an x squared on the bottom, and that leaves you with not a y on the top, but a y on the bottom. So once you get to that point, you can multiply straight across, left to right, and get 4 times 2 is 8, times 5 is 40, and you have x to the 3rd times x to the 3rd, which is x to the 6th. On the bottom, it's 3 times 3 is 9, times 6 is 54, and you have y, y, and y for y to the 3rd, and an x squared on the bottom. So you can simplify once again. You can take out a 2 from each of these and get 20 over 27. X to the 6th over x to the 2nd is x to the 4th, and the y to the 3rd would just stay on the bottom. Of course, the values that you could not have would be x cannot be 0 and y cannot be 0 because you have those multiplied all the way through there on the bottom. Number 10, 4 times the quantity x squared plus 9 over 3, or 4x squared plus 36 over 3, and x cannot be negative 3 or 3. To simplify rational expressions, here's a quick review. Starting at the very bottom of a difference of two squares, the way you identify a difference of two squares is if you have a perfect square, a minus sign, and a perfect square. If you do, you find the square root of each term, put one of each in the quantities, but alternate the signs. That's how you factor x squared minus 1. You could also get something like this, a 9x squared plus, or not plus, that should be a minus, which is going to look crazy here, but that's a minus sign, 36y squared. That is a perfect square, and the way you know that is by breaking it in half and looking at this. This is a perfect square, so is this. So that makes the whole thing a perfect square. Over here, 36 is a perfect square. That's a perfect square. And you have a minus sign in the middle. So find the square root of each. 3x and 6y. Alternate the signs. Sometimes you could have a difference of two squares that looks like this, x to the 4th minus 1. You know that this is a perfect square because it has an even exponent, and the number to the left of it is just 1. This one is a perfect square. You have a minus sign. The square root of x to the 4th is x squared, and the square root of 1 is just 1. Alternate the signs. You cannot do anything with this, so it's just x squared plus 1. But this is also a difference of two squares, so you can break that up into two quantities to get x plus 1, x minus 1. And you may have to do this in the problems that we do to simplify and cancel out, or you may not. If it helps to take it out this far, and you may have an x plus 1 or an x minus 1 somewhere, then do it. But if you don't have an x plus 1 or an x minus 1 to cancel out anywhere, then you really don't have to. You just want to cancel out what you can. Sometimes you could have this, like an x to the 8th minus 1. The square root of x to the 8th is x to the 4th. So x to the 4th plus 1, x to the 4th minus 1. You cannot do anything with this. It stays. But this is a difference of two squares. X plus 1, x minus 1, like we did before. Whoops, x squared minus 1. You can't do anything with this or this, so it just stays where it's at. But you must notice that you also have a difference of two squares at the end again, which would be x plus 1, x minus 1. That would be the complete factorization. If you don't know if 256 is a perfect square, take the square root and find that the square root is 16. That means it's a perfect square. If you don't know that 300 isn't a square root or a perfect square, then take the square root of it and find out that it comes out to be about 17 point something. So that means it's not a perfect square. Your life would be so much better if you knew the perfect squares up through 25, which are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, 400, 441, let's see, 484, 529, 576, 625. if you have something like x squared plus 2x, you can take an x out of both of them and get this. You might need to do this, or you might not. If you have something somewhere else with an x plus 2 on the bottom, or even just an x somewhere that could cancel out, you might be able to do this at some point if it's needed. This example is negative 6x plus 2 over 9x squared minus 1 times 3x squared minus 5x minus 2 over x squared minus 4. This up here, it could be possible to take out a 2, or maybe even a negative 2. If I take out a negative 2, I'm left with 3x minus 1, which may come in useful later. And the reason why that I took out a negative 2 is because I'm looking ahead down to the bottom at that difference of two squares and noticing that when I factor that out, I'm going to have 3x plus 1, 3x minus 1. If I had only taken out a 2 from the negative 6x plus 2, then I would have been left with negative 3x plus 1, and that would not have helped. On this side, I know that my only options for this, if it's factorable, are to make out a 3x and x from that. And I know I have to have one positive, one negative factor for the negative 2. And I'm going to try 3x plus 1 and then x minus 2 and see if that works out. That is negative 6x plus x is negative 5x. So I know I have the right factorization. And of course here on the bottom we have a difference of two squares, x plus 2, x minus 2. So let's see what we can take out of here. Anything that cancels? Anything else? 3x plus 1. Alright, so we're left with what? Negative 2 over x plus 2. And we would have to go through and find the items that x could not be equal to. So from this, you would end up with a negative third, and this would be a positive third. From this, you would have a negative 2, and that is a positive 2. So in order, it would be negative 2, negative 1/3, 1/3, and then 2. This practice problem is negative x minus 1 over x squared minus 1 divided by x squared minus x minus 6 over x minus 1. The first step in simplifying this is to notice that you have this. That means that you're going to have an x plus 1 and an x minus 1 in there. So perhaps something will cancel out with it, and if you look here, this is division. That means when you flip and multiply by this fraction here, that x minus 1 on the bottom goes to the top. So there is something that will cancel out. But also here, if you can change that into something that we can cancel out, like a negative 1. If I take a negative 1 out of this and this, I'm left with x plus 1. Does that help me out? Yes, it does. This is easy to factor. It'll be x and x. You have minus minus, so it's going to be plus minus. And you need to add to get a negative 1, so it's going to be 2 minus 3. So you can knock out this and this, this and this. So you're left with a negative 1 over x plus 2, x minus 3. And the values that x cannot be equal to must come from the following areas. It must be from here, here, and here. So when we look at that, we're going to have this, so it could be -1, and I'll do it on the bottom first. -1, 1. And then over here, it's a 1. We already have that. And from this, which was on the top, it could be a -2 or a 3. So we end up with -2, -1, 1, and 3. Here's a bonus problem. Solve that and leave the answer as a fraction, whether it be a mixed number, improper, or proper. The solution for the first one should be a -2 and 1/3. Here's another bonus problem. Solve this, leave it as a fraction, and unless you come out with an integer, never leave anything over 1. The solution for this homework. Well, I said homework because this was a homework problem yesterday that we went over, and we had one like this before. We stopped and did a review of the factoring quadratic equations. But you cross multiply like this to get 6x minus 4 equals 2x plus 1. Shuffle your items appropriately and come up with 4x equals 5, which would be x equals 1 and 1/4. Answer to the bonus is 1 and 1/4. Your quiz is very short, and it is the following problem. It is 2 minus x. What you must do is explain how I can make that 2 minus x into x minus 2. For this quiz, if you, in some fashion or other, either by words or by working it out, showed that if you take out a -1, then you end up with x minus 2 instead of 2 minus x.
It's almost as fun as you.
This is extra credit. You can do it or not do it. It's worth 10 points each if you show all the work and get them right. Bobby Joe wants me to turn the light on.
Thank you.
Is that better?
Oh, that's better. Yep.
Do this or not, but it's due at the same time with homework. Here is the homework. The homework is practice over some basic stuff that we've done up to this point. So these problems are shorter. On Monday, or not Monday, but tomorrow, you're going to have items that include factoring by grouping, in addition to canceling out with factoring quadratic expressions, differences of two squares, changing the signs of quantities and such.